Okay, I'm recording now. So I was saying
Okay.
before that every cable do have their terminating ends. You see this particular one now, where my cursor is. You see it has
Okay.
different terminating ends. So
Yes.
now, for so far, maybe I've shown you that of terminating end of coaxial and fiber. Now this is my concern. For twisted pair, as I said before, we have UTP and STP, and they have terminator too. And the name of the terminator for twisted pair is, as you said, RJ45. We call it RJ45. Now,
Okay.
this twisted pair is four pairs of cable. One, two, three, four pairs. I mean
Okay.
by four pairs, we have green color on. We have orange color. We
Okay.
have blue color, and we have brown color. They are all pairs. So each pair comprises of solid color and striped color. Like when you see this one, this is green stripe. This is solid color of green. This is brown solid, brown stripe. Orange solid, orange stripe. Blue solid, blue stripe. It's the same thing
Okay.
too. Maybe you can see clearly from here. Twisted pair. Okay, look at it's somehow clear. Let me check if I can get a clearer one. See the way it looks like in real life. See the brown, green, orange,
Oh,
and blue.
okay. Blue.
Yeah.
Okay.
So okay, see it's clearer here. I think this one is better. So now we have a terminator for it. We'll call it RJ45.
Okay.
Now we also have this RJ45. Okay, so this pair now is four pair, and we use four pair for data. Although when I say data, I mean both data as text and even voice. There is another one that is of two
Okay.
pair. It's of two pair. That one is for voice. That's the one that you will see with uh, intercom phones. It's smaller to compare with RJ45. RJ45 is see the shape of RJ45, but RJ11 two pair is RJ11. RJ11. Now see the differences. This is RJ45. So this is RJ45. See the way it looks like. You can carry four pairs, but RJ11 is RJ11 it's almost like RJ45, but it's tiny, it's smaller. Look at it. It's that the one that we use on the phone. It's that the one that we
On the phone. Hello?
yeah.
Yeah. Please, sorry, I went off.
Okay.
So a call came in. Okay.
Okay.
From that, talking about RJ11, that was where I thing went off.
Okay. I was saying before that RJ11 is for two pairs. Sorry.
Okay.
Where did I even do it before? RJ11 is for two pairs. I'm coming. Let me see, bring it up. Okay. I see RJ11 is for two pairs, while RJ45 is for four pairs. And RJ45 is for data. You use for to carry data when you are transmitting data. While RJ11 is for voice. It's not as though you cannot use voice on RJ45. You know that when you are using voice over IP phones, it's RJ45. Voice over IP for most of them, you can actually browse through them, even send message as text. So they carry data and voice. So you can still use RJ45 in it. But just know that the difference between RJ45 and RJ11 is that RJ11 is smaller and it's for voice, while RJ45 is a little bit bigger and it's for 4 pairs. It carries 4 pairs. As you can see from here, so this is RJ11. This is RJ45 still. So see the two, they brought the twin. This smaller one is RJ11. This bigger one is RJ45. But even if you can't see it well, it's the one that we use on our intercom phone. The one we call intercom phone. It's always
Yes,
smaller. So we
yes.
call that head RJ11. So still back to what I was talking about, twisted pair. I said twisted pair has about 4 pairs of cables: green, orange, blue, and brown. Now, just take note that green and orange are data cable. Data passes through these ones. I'll talk more about that later on. Now, with the fact that there are 8 pairs, whenever you want to terminate them, there is a scheme, there is rule on how it's supposed to be terminated. You can't just bring um, the cable. I said a twisted pair has 4 pairs of cable: green, orange, blue, and brown. And green and orange are data cable. I'll talk more about what I mean by their data cable. Data passes through the two of these. I'll talk more about that one later on. Now, whenever you want to terminate the cable, there is a scheme, a way we do it. You can't just bring in an RJ45 as just to, you can't just bring it and terminate. See RJ45 as it is. You can't just bring it and slide the cable inside and terminate. You can't just do it that way. There is a way to do it. There is something we call scheme. Now, the way of doing it or the scheme of cabling is we have two schemes. We have T568A and T568B. These are two schemes that you can actually use to terminate cable on RJ45. And when you look at it as it is, that of A starts with stripe green, sorry, bold green. Okay. Just know that both of them do have at the end brown. Brown is always at the end. Then both of them at the center is always blue. You can see it's blue at the center. But the only difference between the two is that the beginning part of A starts with orange, while the beginning part of B starts with, sorry, orange. This one starts with green, this one starts with orange. And in this case, in that of A, orange engulfs the center, while in B, green engulfs the center. Orange starts, green engulfs. In this case, green starts, orange engulfs. It's very important that you memorize this as a network administrator on how a cabling scheme is structured, so that whenever you want to terminate a cable, you just follow any of these schemes. You can actually use any one, maybe A or B, any one that you care about. You can use any particular one of your choice. But under best practices, you're meant to use one. Because it's not that if you mix it, that something will go wrong. No, not having a uniformity, doing everything in uniform might look like someone that is not organized. So in every whenever you are setting up a network as a new installation or you are maintaining, always always go with a particular one. If you're using A, you use A or true. If you're using B, you use B or true. I've also, like, if you get into a place where you want to maintain a network, you want to troubleshoot or something, just check what the network has been using before, existing cabling. If the existing one is A, it continue with A. If it's B, it continue with B. Not that if you mix it, anything will go wrong, nothing will go wrong, but it's not professional to mix it up. Now, normally you are meant to know how to cable or terminate cable. Is more of practical. You're coming in tomorrow, right? Hello? Hello?
I'm coming tomorrow.
So when you come tomorrow,
I can hear you. Can't you hear me?
yes, I can. I just want to know whether you got what I said.
Okay.
Okay. So if you when you come tomorrow, I need to show you how to terminate cable. If you don't know about that before, it's important that you know how to terminate cable. Or even if it comes to what, you can still check YouTube on how to terminate cable too. But for us to check YouTube, it might take our time. But just know that that's how to terminate it. You have to arrange your cables this way. If you're using, you have to arrange it this way or that way before you now slide it into the RJ45. See RJ45. When you finish arranging it the way I showed you, the RJ45 is supposed to be sorry, I'm coming. Okay, look at this. You see this RJ45, this particular one at my left, at your left. Can you see that? Hello.
I can hear you. I can see it. I'm
Okay,
answering you.
okay. Now, when you finish arranging your cable the way I showed you, either you are using A or B. When you finish arranging it, either way, either this way or that way, as the way is facing now, because the cable, when you are arranging it, assume that you arranged it like this. Assume that this is the cable, and this is the way you now arranged it. This one is the insulator that covers it. So these are the cables and all of that. So if the starting one is green, if this particular one is green and all of that, if this one is green stripe,
Okay.
now when you finish arranging it, assume that you are taking A. When you finish arranging it, the way you're supposed to slide it into the RJ45 is you allow the RJ45 the opening to face you. The clip is supposed to be under. So when you allow it to face you like this, sorry, when you allow it to face the opening to face you like this is the way you now slide it in. As it's facing you, the clip is supposed to be under. You
Okay.
understand? Not that the clip will be on top. You know that the clip, if you mistakenly invert this clip, you will miss it. So whenever you are terminating, your the RJ45, the opening should be facing you. Then the clip supposed to be under. So you now use this. We must have done this. You can now slide it in. So that's the way to
Okay.
terminate it. When you terminate, you now use clipping tool to clip it. Clipping tool is. I will still show you that maybe when you come in tomorrow. Clipping tool.
I know it.
Okay, know what it is. Okay, that's use this to clip it. That's the clip it tool and all of that. So that's that for um cabling scheme. Now, whenever you terminate one end, if you're terminating one end as A, the other end is supposed to terminate it as A. If you terminate one end as B, for instance, the other end is supposed to be B. And when you do like this, one one end, if they are the same at both ends, that kind of cable is called straight through cable. Straight through cable. It's called straight through cable. That's what we call it, straight through cable. If one end is A and the other end is A, we call it straight through cable. But if one end is A, like you can see here, and the other end is B, it is called crossover cable. Crossover cable. That's the spelling, crossover cable. You see that the beginning part of this one is green.
Yeah.
while the beginning part of this one is orange. So this one is A, this one is B. So when you have such cable as this, it is called crossover cable. Unlike straight through
But
cable.
what is different? Why will somebody cross it? Will it still work? Do it like that?
Okay, there are places or there are connections when there you need to use crossover and when you need to use straight through. Now you use crossover. Let me start with crossover. You use crossover on like devices when you're connecting like devices. An example of like devices is when you have something like this, you're connecting PC with another PC, or you're connecting switch with another switch, or you're connecting switch with hub, or you're connecting hub with hub, or you're connect like now PC with PC, switch. Sorry, let me make it clearer. So when you're connecting PC with PC, just as what we have here, we are doing pair to pair, or when you're connecting switch to switch, or when you're connecting router to router, or when you're connecting hub to hub. So when you're connecting the same devices, you use crossover. That's what we call like devices. And also switch and hub are referred to as the same like devices, and PC and router are referred to as like devices. So whenever you are having this kind of connection, you are meant to use crossover cable. But straight through cable, you use straight through cable when you are connecting unlike devices. For instance, as we have here, we are connecting PC with a switch. They are unlike devices, or you are connecting switch to a router, or hub to a PC, or even uh, what again now outside
Maybe,
this
okay, maybe like
even
router
s-
to
even
router
switch. He said
to switch.
router to switch. Yes, that's router. It's still this too. Router to switch and PC. Even okay, PC to hub, PC to switch, switch. I think that's all. When you have PC to switch, hub to PC, switch to router, they are unlike devices. So in such cases, this is where you use straight through when you are dealing with unlike devices. Now you
Please,
should
I,
also
I want to, for the cross switch, so I'm going to learn the way it's being arranged, right? I
yes,
noticing that the only one is like the brown that is down. The
yeah,
other ones are like
yes. The only thing you interchange is the data cable. Um, it's only the data cable, the greens and
and
the
orange.
orange. Every other one is the same. If you're using A, you start with green, stripe green. But if you're using B, you start with orange, stripe orange. So if you're using green, that means orange will now engulf the center being the blue. If you're using orange, green will now engulf the center, which is the blue. And also be mindful that you always start with stripe. But in blue, bold, solid start first. This one is still stripe first. It's only in blue that you start with solid color before the stripe in two of them. So I've thought about where we use crossover and where we use uh, straight through. Okay, now I was saying something about um, that green and orange are data cable. Now, what I mean by that is that data passes only through the green and the orange. Now, when this PC wants to transmit, it will use this green to transmit, and this switch will receive with green, these two greens. Now, when this switch is responding, it will use orange, and this guy will now receive with orange and orange. So every transmission and reception is done in orange and green. They are data cable. Other cables are reserved. I'll talk more about that later. They are reserved for PoE technology. I will explain things about that. Now, when you terminate your cable, when you terminate your cable, you will need to test it, be sure that it is well terminated. And you test it with equipment we call LAN tester. LAN tester.
I know it.
So this is LAN tester. This is image of LAN tester. So in LAN tester, when you want to test your cable to be sure that it's fine, you put one cable here. You can see this particular
Okay.
one.
I want to find
Okay.
I want to find out this land tester.
Yeah.
You know, we talk about fiber optic cable and the other one coaxial cable.
Yeah.
Those other ones they have tester too, or they have the same port that we can use to give the same LAN tester that we use for the three, or they have their own specific tester
Okay.
too.
They have their own tester. Fiber on
So,
the tester or the equipment for fiber is very costly. You can't just, it's not everybody that can afford it. And besides, for fiber, if you're in an organization where you have fiber issue, you want to test the cable, be sure that there's a connectivity. You have to call people that have the machine. There's a machine that tests. It's very costly. It's not people. It's not everybody
okay.
that affords it. So just a
So I want to
special.
find in
Okay.
Nigeria now.
Yeah.
Nigeria,
Yeah.
we have the fiber machine. Like, what is the average usage? Because what I know is that most companies use this time. Um, this cost this our normal cable. This are the 45 cable.
Yeah.
This fiber is already in use in Nigeria.
Yeah. It's in use in Nigeria. It's been used. You can actually get fiber, short fiber cables in market. You know, I explained something
Okay.
before about okay, when I was showing something about switch, the giga. Okay, let me bring it up
Yes.
again. I was saying something about
Yeah. And
switch
fast.
gigaport. Now, this gigaport, now most of the switches now are made up of the gigaport. You use fiber on them, and that port for
Okay.
fiber. Look at it now. You know, it's not. If you look at it well, you see that the port is different from fast Ethernet.
Yes.
Yeah,
Exactly.
um it's not like, let me bring another switch that is not, that still have gigaport. See this one, it has gigaport, but
This
it
one.
looks like fast Ethernet too. You see, they resemble, but
Yes.
this one is giga
Okay.
Ethernet port. But in this case, this one is giga Ethernet, but it is not as,
For answer.
it's not a giga Ethernet port, but it is what we call, this one is SFP port. SFP. SFP, I don't know the full meaning, but that's what I know about. SFP is for fiber. SFP, let's say SFP port. You will get the full meaning from there. You see that SFP. Okay, it's even good that I even done it. So SFP port is for fiber. Now, for switches, when you are buying, you can actually get one that has SFP port like this. It's even written SFP port.
Okay.
And most of the fibers we have in market are terminated like this. Can you see my cursor? You see where my
No.
cursor is?
No. Can you shake it, please?
Yeah. Okay, let me open it.
Okay.
So most of the fibers in market, their head is always like this. And their head can go
Okay.
in. You see the way this man, this finger is going in now.
Yes.
So most of the fiber come with that. See it too. The ones that you can see in market, in Nigerian market, are like this. Their head is always like this. Don't mind about this. This one is a fiber patch panel. This one is for special purpose. Maybe you
Okay.
have a very big company that has so many that is dealing with heavy heavy data. You might have your patch panel, everything connected with fiber. You see that this head is different
Yes, it is.
from this particular one. So it's when you have, it depends on what you are looking at. But this one is, you have a special kind of, it looks like a switch, but we call it fiber patch panel. But most of the fibers, short length fibers, you see market, their head is always like this. So you can actually use it here. Can I see one? Um, if I can get one. Yeah. I know that their head is always like that. I want to see if I can get one. Okay, look at it here. See the one that has been used. Can you see this particular one?
Okay.
Yeah. So this is the one. See the way they look like. So you just slide it inside that SFP port. So you can buy, if you go to the market,
Okay.
it's in market. It's in Nigerian market. So when you're buying, most of the switches do come with SFP ports because fiber is already available in market. Instead of using, maybe now if you want to connect it from here to a router, and the router, most of the routers do have their own SFP port as well. You just need to go and buy fiber cable in market, connect from here, then connect to the router. One thing with fiber is that it carries heavier data. The bandwidth of fiber runs from, I think, from 10,000 10,000 Mbps. So it's very fast. It can carry um, heavy data, heavy traffic. So that's just that. I think it was a question that you asked that brought me to this. I haven't forgotten
Yes.
where we were before. Okay, I think I was here. I've thought about like and unlike devices and where we use the cable, and I've thought about how we terminate cable using RJ45.
Yes.
Okay, I was on land tester when you now asked the question. Okay, because I was on land tester, you were asking whether fiber do have their own, are they using the same? I said they are not because they have their own testers, but fiber own is costly to buy.
Okay.
So see land tester, see the way we use it. You just put one end here and put the other end here. The it will not be reading.
Okay.
Now it will not be reading 1, 2, 3, 4, 5 till 8. If it jumps, the light, the LED light, if it jumps, it means that there's something wrong with that cable. Like you can see from this image now, this one is reading 5, this one is reading 5. So if you enter C, this one enters C at the same time. And it will read from 1, 2, 3, 4, 5, 6 till 8 and now start up again 1. So if it jumps any line, you know that something is wrong with that cable. Now with
So what you
that,
mean is what you mean is that it has to read from 1 to 8 without jumping.
yes, it's supposed to read from 1 to 8 without jumping. So if it jumps, that means something is wrong with the cable. The cable is not well terminated. See the way it's supposed to be fixed. You put one end here and put the other end here. They will now read all in, they will read simultaneously and they won't jump. If they jump, that means that cable is not good. So that's that for the person that is testing it. So that's that for land testing. Land tester. Now, um, now for your exams, in your exams, if they want to ask you question on this, they will ask you question based on the numbers. You see that they are lined up 1, 2, 3, 4, 5, and all of that. So your exams, they might even ask something like, they will ask if a PC is transmitting to a switch using straight through, it might transmit through 1 and 2 cable, one port, that is number one and number two, pin one and pin two. They might ask you the one, which port will receive it?
Okay.
It's still pin 1 and pin 2. The same thing goes to crossover. Crossover, if this one transmits with pin 1 and pin 2, it will be received from pin 3 and pin 6. You see that green will still locate itself. See green, the end of green will still
Yes.
locate itself. But at the other end, it will now form,
Okay. So
enter as pin 3 and pin 6. Because here is A and here is B. You know, A is starting with green, while B is starting with orange. So in crossover cable, transmission will enter from 1 and 2 and be received at 3 and 6. Then this one will now respond with 1 and 2. This one now receive with 3 and 6.
okay.
So you should note that too. The numbering
Okay. Okay.
and all of that. Now, the other cables are reserved. The reserved cables are blue and brown. Sorry, I better use um, where is that scheme? Okay, I think I better be using this. Okay, now blue is blue and brown. We are reserved, and we are reserved for PoE. PoE is a technology. We call it power over Ethernet. Power over Ethernet, as in power over Ethernet. Power over Ethernet. That's the pronunciation. Now, power over Ethernet is just a technology that allows power and data to pass through cable at the same time. You know that if you network your printer, for instance, if you network your printer, this printer now, you connected with a cable. You can never print from this printer if this printer is not powered. Normally, this printer will have a power cable that you plug to electricity.
Yeah.
So if you don't plug it or it's not powered, it will never, nobody will be able to print from it. The same goes with the scanner and all of that. But there's a technology we call PoE technology that powers a device through the cable. And we call it PoE as a PoE, power over Ethernet. Now, any device has this switch that can give as an output power and data at the same time is referred to as PSE, power source equipment. Power source equipment is not all switches that are PoE switches. PoE switches are written on it and they are more costly. They are the same, it's not switch, they are the same, but only that the functionality changes and it's always written that it's PoE. Like you see this one, it's written PoE. Look at it, you see PoE. So every
Okay.
PoE switch, they are always written that on the switch. Now, so like this switch now can be 24 ports. In fact, it's even 28 ports. 24 plus 4. Sometimes you see them, they might say that 12 is PoE. They might say 12 PoE. It means that 12 is PoE and 12 ports are not PoEs. But some are all PoEs. They are always written. If it's not PoE, you will not see it written anywhere. If you check the switch, you will see somewhere that is written PoE. I don't know whether we can zoom this, but it's always written in front. When it is tiny, you can't see it. So every device, switches like that or router that is PoE. That means it can give out data, and power at the same time. Those devices are referred to as PSE, power source equipment. Now, equipment like cameras, cameras, alarm, and radios, radios. I can't remember much more, and even voice over IP phones. Voice over IP phones. Most of these gadgets now, the technology that are being used to design them now goes with PoE in such a way that when you mount a camera, you don't need to power it. Like you don't need to. It doesn't come with a power cable. The same goes with alarm and radios. Radios you see on the mask and voice over IP phones. They don't come with power cable. So when you connect them, if you connect camera to a switch, it receives data and power at the same time. So such equipment that has PoE made on them, like camera, alarm, radios, and voice over IP phones, are called PDs. That's powered devices. That means that when I say a, a device is PD, I mean that it is it has a PoE technology. It doesn't have a um, power cable. So it receives its power from PSA. Now we should also know that we have PoE technology, we have PoE, we have PoE plus technology. We also have PoE plus, PoE plus plus. Now I think this one started 2009. This one started 2000 and I think 2012. This one 2018. It was even Cisco that developed PoE plus plus. Now, PoE, the technology differs. I know that they have different. I will expect you to check that up again on internet, more about that. But what I can remember is that PoE as a technology makes use of 24 volt output. So if a PD like a camera or alarm or voice over IP phone is a PoE, it means that its voltage, input voltage is 24 volts. While PoE plus, I, I think their voltage is 48 volts. This one is 48 and above. Now there's something about this particular PoE plus. PoE plus, a gadget that comes as or comes with this technology, PoE plus, comes with what we call PoE adapter. PoE adapter. Let me show you what it is. PoE adapter. PoE adapter. So see, look at the PoE adapter, the way it looks like. Now the way we use it is look at here. In PoE adapter, the adapter itself, you power it. Then you take a cable from one of its ports, written PoE. Like when you look at this port, here is written, if you can see my mouse, here is
Yes, I
written
can.
PoE and here is written LAN. So the one that is written LAN, you connect it to the switch. The one that is written PoE, connect it to the PD device. You connect it to the PD because that's power device. Like this one now is a radio. So if it is a camera, it connect from here to the camera. If it is alarm, you connect from here to alarm. If it's a voice over IP phone, you connect to that to voice over IP phone. Let me see if I can get something that is reasonable. Oh, I can't see something I can use for that. But just that's the way it is. Okay, look at this. I think I can use this. Now, um, where is oh this one is a complex connection. Forget about this one. This one you have to master something. You might not understand this yet. Just let me get you to understand what POE is first before we start doing some complex connections. Um, so maybe I have to on camera. Sorry, hold on. I'm checking. I want to see, get a good picture. Okay, I think I can use this. Okay, look at this camera now. This camera gets its power from PoE. So sometimes you call it PoE injector. So you see the connection. This is a switch. This is a router that has a switching port. So you connect from this switch to the port written LAN on the PoE injector or adapter. Then you now connect from PoE port to the camera. You understand?
Yes. Okay.
So when data enters here, it go in here. This when it goes into the injector will now send the data out together with power. Now you can actually use. You may not necessarily have a switch that is PSA. Whether it is PSA or not, as far as you have injector, you are good to go. So now you seem to understand some things too. I said before that for PoE, they don't gadget that is just PoE do not have PoE injector. They receive their power straight from the switch. Straight
Okay.
from the switch.
That
And
POE, what do you say the POE mean?
sorry, hello, hello.
Power what? The
Power over Ethernet. So for PoE, any
For
gadget,
PoE, any gadget.
hello, hello.
yeah, I think you lost connection or something.
I'm sorry. A call came in. I was trying to ask that POE. That what
Okay.
does it stand for again? Power, no, the E is equipment, right?
So PoE is a power over Ethernet.
Okay, power over Ethernet.
Yeah. Ethernet as this spelling.
Okay, power over Ethernet. Okay.
Ethernet.
But the
Yeah.
PX is power system equipment, right?
Power source equipment.
Equipment. Okay.
Why
Then PD is
PD is
device.
powered device.
Okay.
So powered device is the one that is getting power from a switch. If this is PoE switch, so PoE switch, if you hear anything PoE, it has its own power. But what I know is that PoE technology always goes with 24 volts.
Okay.
And if this PD is just PoE, I don't need it won't come with adapter. It won't come with injector,
Okay.
PoE injector,
Okay.
except if it is PoE plus or PoE plus plus. They come with their own injector. So if it comes with its own injector, whether you have a PSE or not, it does not matter. The injector will do the job.
Okay.
You understand? Now, also, if I have a
So that,
PD, okay,
that means that one can buy, can one get that injector alone
yes, you can.
and
You
use
can buy
enough?
it. Yeah, it's a market. For instance, now, you have a switch already in the network, and a manager wants to buy voice over IP phones, maybe one or two, and it can't just because that you are buying phone, maybe two or three phones. You now be like you want to go and buy a PoE switch. You can just still use your old switch. The only thing that you need to do is that you go and buy injector that is 12 volts.
Okay.
So you just put that injector here. So when data comes to the injector will now take the data and power the phone. So that's just that.
Okay.
But a device that is PoE plus always have injector, PoE plus plus like that. There's more to this what I've explained, but I just gave you general. I just gave you general overview of what PoE is. But I will expect you to check more on it on internet. You get more information about that. So that's that for PoE. From what I was talking about, um, reserved cables. They are reserved for PoE. Now, if you are dealing with PoE, the blue, the blue cable, one is positive and one is negative. If you are connecting to just a PoE device, well, a PoE that's okay. Now, if you're connecting to a PD that is made up of PoE technology, are you there? Hello.
I'm here.
Okay. So if you you are connecting to a PoE, that's a PD that's been uh, designed with PoE technology. It means that when the PSC is powering it, PSC will use this. It uses blue, positive and negative as power. But if it is PoE plus, it will use both blue and brown. You understand the difference now? PoE uses only blue for its power. The blue cable has its power, but if it's PoE plus or PoE plus plus, it uses the blue and the brown. That's just that for PoE. So the other cable, orange and green, are data cable. So you understand why what I was talking about data cable before, just to explain that. Now, for so far, I think that is what you need to get know about cabling for now. Then, I started with what is host, what is peripheral, what is network device, and media. Media, we've talked about fiber, coaxial, and the just one you just concluded now, twisted pair. Now, I will talk about wireless later on, not today. I'm coming back to network devices. I said before that network devices, examples, were hubs, switches, and routers. Now, I'll be dealing with them now. Hubs, switches, and routers. I'll take care of them now. Okay, I was starting with hub. Now, what I will do is that I will explain to you the way they operate, their functionalities, so that from their functionalities, you now know the difference between hub, switches, and routers. And you even see the reason why hub is no more in market, is outdated, it's waste of money and waste of time, even to use hub. Okay, hub, I've already shown you the image of hub. one time on internet. I think I've shown you that once. It's like it looks like switch, only that the way it functions differs. Now, the way of hub
What
function, I want
about
to explain. When you connect hub, or let me start this way. We have
please?
hub,
Yes, sir. Hold on,
yeah,
hold on. Give me a minute, please.
15 minutes.
A minute, 1 minute.
Okay, okay. Now I'll be dealing with hub, switches, and routers. Now, one of the differences between hub, switch, and router is that hub does not have memory at all. While switch and router do have have two types of memory. They have RAM and NVRAM. Now, it's just this thing to know that switches and router they are C computers as well. Now, in your normal computer that you know have RAM. Are you still there?
I'm here. I'm here.
Okay. So the computer that you know has RAM as memory. Now that RAM is we call it a random access memory. It's just the memory that keeps your activities uh, in real time. Just as when you are typing something on a Word document, as you're typing it, you can read everything that you've typed. But if eventually light goes off and possibly maybe you're using a desktop that is not powered with a UPS, everything wipes out. So whatever thing that you must have typed, they will all wipe out. Why? Is because where you are typing it is saved on the RAM, and RAM is volatile. When power goes off, everything that is on RAM wipes out. Now, for you to save your work and still recover it, when you save, it is saved on the hard disk, right? So even if something goes wrong, maybe when the power right takes off and all of that, your work is still saved on the hard disk. The same thing is applicable on the switch and router. Switches and router they have RAM and NVRAM, and RAM functions as the same what you have on the computer system. So when you are making any configuration on the switch or on the router, that configuration stays on the RAM. If light goes off, everything you've done on the switch or on the router wipes out. But if you want your work to stay, when you do a configuration and you save it, it saves on the hard disk of the switch or the router. And that hard disk is what we refer to as NVRAM. That is non-volatile RAM. Non-volatile. Non-volatile RAM. So this non-volatile RAM. So your work is saved here on non-volatile RAM. So switches have RAM and NVRAM. The same with routers, they have RAM and NVRAM, but hub do not
That's
have
out.
memory at all. That's number one. Now, other things you need to also know about hub is that when you have a connection like I have here, you have computer one, two, three, four, and all of that connected to a hub. Now, whenever a system, a PC, wants to communicate with another PC, for now, this PC source H2 wants to communicate with another PC. This is destination. When it sends message to hub saying, I'm sending message to this particular one, maybe this one is PC7, for instance. What hub will do is that hub will broadcast the message to all the active ports on the hub. What I mean by active port is connected ports. You know, a hub can be maybe 24 ports, but you might be using 8 ports as you can see here. So the active port on the hub is 8, in as much as the fact that it has 24 ports. So those ones that are not connected is not accessing them. Are you there?
I'm here.
Okay. Now, when H2 sends message to H7, when it gets to hub will broadcast the message to all active ports apart from where the message is coming from. For instance, now H2 sends to H7. When it gets to hub will now send message to this, 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 send message to this. That's broadcast message. And apart from where it is coming from. All right. Okay. So when it happens like that, it will broadcast the message to all the active ports. Now you see that these ones will now reject the message because the message was not addressed to them. See that they rejected it. They rejected the message or they ignored the message. The only one that will accept it is the one that has the message. Every other one will ignore the message. So that's that the way hub function. And also another thing you need to know about hub is that, sorry, let me see if I have that here. No, yet it's not there. Okay, another thing you need to know about hub is that when any message, when more than one message enters the hub at the same time, there will be a collision of the message. When I mean a collision, the two messages will come together and now become corrupt. For instance, if H2 is sending message to someone and this one is also sending message to another person, and if for any reason that the two messages enter here at the same time, they will collide and become corrupt. What I mean by become corrupt, the message will become useless. We call it garbled message. Garbled. And one thing Hub will do is that Hub will still broadcast the garbled message. The message that is even corrupt, that is useless, it will still broadcast it. So that is one of the things that, and you see all these features that Hub has that makes it non-useful again in the present technology. Now, coming to the switch. Switch do not behave like hub. Now, the way switch do is that when a source like H3 is sending message to destination like H7, H8, for instance, the switch sends the message straight to the owner of the message without broadcasting it. Now, for switch to do that, are you there?
I'm here.
Okay. So, for switch to do that, switch will first of all fill its ARP table. There's a database inside of the memory of the switch. We call it ARP table. ARP table means address resolution protocol table. Inside that table, it contains MAC address table as well. Now, MAC address, you might be asking me what is MAC address? MAC address is the address given to the Ethernet port of a device or a host from the manufacturer. And MAC address cannot be changed, it is always unique. Are you there? It's like you lost connection.
I'm here.
Okay. So if I want to see the MAC address of my system, I'll go to command prompt. I will teach you this one later on. I'll do this. I will talk about this when we get to that. So the MAC address is the physical address. Look at now. I have this Ethernet adapter. This is my Ethernet LAN adapter. See the physical address is 6E 6A, CA, BD, and all of that. That's the MAC address of my Ethernet adapter. My wireless LAN adapter has its own too. C8 and all of that. And MAC address is 48 bits. It's important you know that it's 48 bits. So all your
The 48.
adapters, network adapters, do have their own individual um, MAC addresses. Okay. Now, as I was saying before, that switch has a table, a database called ARP table. And that ARP table also contains MAC address table. So what does switch use ARP table to do? What you do is that whenever, ah, sorry, am I cleaning? So whenever, um, so hold on please,
Please.
share, hold on, pushes.
Purchase.
Okay, now for ARP table, which also has MAC address, whenever you have a fresh connection on the switch, just as now, I just installed this switch and connected the host together. The ARP table of the switch is always blank, as in empty. So if H1 wants to communicate with H7, it might start to ask who is H7. It will not ask switch who is H7. And switch does not know H7 yet because everybody just get connected. So you now ask if H1 is asking who is H7. Switch will now broadcast the message, send it to H2, H3, H4, H this, and all of that, all of that, all of that. Every other one will ignore the message. They will ignore the message. Only H7 will respond saying, I am H7. Now, when it responds, before switch broadcast the message, when H1 is asking who is H7, H1 will see introduce itself in the message. So gets when switch gets the message, switch will secretly register the MAC address of H1 in its ARP table. Very possible this is the MAC address of H1. Maybe H1 is connected to fast Ethernet 1. Now, when H7 responds, I am H7. So switch will now be like, okay, H7, this is your MAC address, and you are connected to my fast Ethernet port 0/7. So this is the way switch takes note of uh, hosts that are connected
Host.
to it and fill its ARP table. Now, if it has knowledge about H1 and H7, now for instance, H2 would that be now asks who is H1. When he asks that, switch will no longer broadcast the message. Why? Is because the information about H1 is in this ARP table. So it will just tell H2, oh, H H1 is so and so. H1 is so and so. So the only time switch will broadcast the message is if the record is blank in the ARP table. You understand? Hello?
I do. I understand. I'm following you.
Okay. So
Got it.
that's the way it fills its ARP table. Now, when it fills its ARP table, what I mean by when saying if H1 is asking, if H2 is asking who is okay, let me use H3. If H3 is asking who is H8, H3 will know the IP address of H8, but it doesn't know the MAC address. So what is actually asking is what the MAC address of so IP address. I don't want to confuse you anyway. But just take it that it's asking who is who. Now, I've explained how switch fills its ARP table. So when someone is asking, the person will put its own address. So switch will secretly registers the address. Why is asking broadcasting who is who? So whoever that responds, it will still fill the ARP table. Now, the ARP table does not stay forever. There's something we call aging time. Aging time. Aging time is the duration of a record in ARP. This is a record. Now, if this record is for H1 and H1 never communicated with any host and no host communicated to it within 300 seconds, in the space of 300 seconds, H1 did not communicate with anybody and nobody communicated with H1, switch would delete the information about H1 from the ARP table. So agent time is sorry, I need to put on front. Agent time is just 300 seconds in switch, but you can actually change it on the switch. So it's very important that you know that, but under default, that's the agent time of the switch. Okay. Now, if the ARP table is filled up and someone now came in, maybe another person, H9 will stay for some time. If nobody talks to H9 and H9 did not talk to anybody for some time, H9 will automatically introduce itself to the switch. So this is another way switch fills its ARP table. Can you hold on please for a second?
Okay.
Just hold on please a second. Okay, I am back. So that's the way switch fills its ARP table. Then I just want to be sure that you've understood.
Sorry,
Okay.
the ARP and the R is which one? P is protocol. Sorry, what's the A again?
Okay. Address resolution protocol.
Yes.
Address
Protocol. Okay, address.
resolution protocol. Resolution is this. Sorry. Resolution is this is resolution. Or maybe just get to internet. So internet will tell us more about that. ARP table. So ARP means look at it. Address resolution protocol. So that's that. So the only time the only time switch sends broadcast message is only when it does not have information about such ARP, such a MAC address in its ARP table. Now, broadcast in switch is what we call flooding. We call it flooding. Flooding is what we call broadcast in switch. When switch broadcast, we say switch flood. Flooding in switch is broadcast. So, um, what again do you need to know about switch again? Um, okay, for now, if there's any other thing, I'll still get to you back. But I want to ask you a question to be sure that you've understood this MAC address of a thing. Okay, before that, I made mention of broadcast. Broadcast is when you are sending one to all. Have I made mention of a message pattern to you before?
No, no.
Message pattern. When I said unicast, we have unicast, we have multicast, and broadcast.
No.
I'll still talk about it, but let me just give you a little, um, a little overview about that. Okay, I think I've seen what I'm looking for. Okay, now when we have message patterns, three types of message patterns as a message pattern. Message pattern. That's message. Message pattern. We have unicast. Sorry. We have unicast. We have multicast. Multicast. And we have broadcast. So these are three message patterns that we have. Unicast is when one one device is talking to another device directly. So this is a unicast one to one. No, uni is just one. One to one is unicast, but broadcast is one to all. Just as you can see from this system. See, this thing is talking to everybody. It's talking to everybody. So such message pattern is referred to as broadcast. We are sending message to all. But unicast, but multicast, you are sending to some. Now that these people, there are five here, but this host is sending to just three. These two are not part of the message. So such message pattern is referred to as multicast. So we have unicast, broadcast, and multicast message patterns. I'll come back to this later on. But just know that we have message patterns like that. So um, I've explained how switch fills its ARP table. Okay. If you've understood what I've explained, I might need to ask you some questions to be sure that you've gotten it. Uh,
Okay.
for instance, okay, let me use this. If ARP table here on the switch are blank, or hold on, sorry, please, shit, S- sorry, please, don't call me. Please a second. Okay, now I want to explain, make this thing more complex. Now, if, for instance, H1 wants to communicate to H2, you know that this is hub.
Yes.
The way message is going to go is that the message will move from here and get to the hub. Hub, because of the way it operates,
Not
it will send message to all active ports. So this one will receive it, this one will receive it, this one will receive it, even here will receive it. Every other person will
okay.
ignore the message. It's only H2 will respond. Okay? Now, if this place H11 is sending to destination H3, when the message gets to this place, if ARP table is already filled up, it will now move and move. When it gets to the hub will do the same thing it used to do, send to everybody. So everybody will ignore the message. It's only this guy will respond. Okay. Now, if ARP table here, if there is no ARP table here, or if the ARP table is blank, and this let's say this source is asking who is H3. If here is blank too, the way it will happen is that it will get to this place. Switch 2 will ask who is H3, who is H3, who is H3, who is H3. This one will not get who is H3, who is H3, who is H3, who is H3. It will get to this place. Who is H3, who is H3, who is H3, who is H3. H3 will now respond. Every other person will ignore. Now, when source is asking that, these people will secretly register the MAC address of H11. This one will secretly register MAC address of H11 and how to reach H11. Switch 2 will register MAC address of H11 and say to reach H11 is through maybe port F11. This one will now register H11. How to reach H11 is through this port. So they will all register and fill their ARP table. But if, for instance, this one has, okay, this one has ARP table filled up, why this one does not? And H11 is asking who is H5. It's asking who is H5. When he gets here, this guy will flood it. But when he gets here, since ARP table here is already filled, switch will just respond without flooding. You understand? So the only time switch floods um, messages is only when the ARP table is blank. You understand? Then
Yes, I do.
can I give you another scenario again? Or maybe I'll ask questions. Then from there I'll explain more.
Question.
Let me just ask you some questions. If it's like you lost connection a bit.
No, I will.
Okay. So if this source is asking who is H3 and
Which source?
H11. I think I've explained this one before. Let me use another
Okay,
one.
H11. Okay.
No, let me use another one. Let's say H1 is asking who is H9 and the ARP table here is blank. ARP table here is blank. So how is the message going to go and the people that will receive the messages?
Okay.
Okay.
H1 acts, it sends to the hub.
Okay.
Then the hub will go
Okay.
to A4. Then the hub will go to the switch, the first switch.
Okay. Switch one.
Then the switch one
Okay.
will register. Okay, because it's not. Then um, pass it to the switch, to the host under it.
Okay. Or the
Then it
host.
takes it, yeah, all the host under it. Then it passes to switch two. So switch two will check, and
Okay.
H2 when H2 H11 files, we will now register it
Yeah.
on body,
ARP table. Yeah.
but aware of it because we'll pass it to all the hosts.
Okay. Okay. One more thing too. Let me ask again. If H. Okay. Let me. If H8 is asking who is H12 and ARP table here is filled up. So how is the message going to go? H8
H8,
is asking who is H12, whereas ARP table here is filled up. How is the message going to go, and who are supposed to get the message?
H8 is asking, we
Yes.
go through
Switch
the
one.
switch one,
Okay.
before we go to the O host under it.
Okay.
If there is none, it goes to switch two. But because it's filled up, it cannot register it again. This table is filled up. But switch 12 will signify to
Okay.
switch two and switch
Yeah.
one, but it won't.
Your network is breaking. Hello.
I can hear you. Can you hear me?
Yeah, okay, now, yes.
I said, well, I said from switch one, it goes to switch two.
Yeah.
But because switch two ARP filled up,
Yeah.
it will um it will broadcast it, but not register it.
Okay, no, if HR ARP table here is filled and a message is asking who is H12, it has knowledge about H12 already because ARP table is filled up. It will just respond that H12 is so and so. It will not ask again. It will not ask these people. Because even if it asks, if it doesn't have knowledge about H12, it will not ask. When anyone responds, it will now give. But since it already know who H12 is, so it's not going to ask anybody. It will just respond that H12 is so and so. You understand? Okay. I will ask another question to just to be sure that you've gotten it. Then if and not only that, I asked before H8 is asking who is H12. Here, ARP table is filled up. So the way the message goes to go is that message will go like this, enter the switch. Switch will now flood the message to here, here, and here. So this one will still receive it, this one will still receive it, this one will still receive it, this one will still receive it. And when it gets here, switch 2 already know who H12 is. It will just respond that H12 is so 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 and so. So switch only floods when it does not have the record. Yes, in the RFA table. So if it has, it will just respond and give uh, the address of who owns it. Then let me ask again. Um, okay, what of if ARP table here is blank, here is filled up, and H2 is asking who is H7? Tell me how the
Wow.
message is going to move, who and who is going to receive the message.
Okay. Um. Now you said switch one is filled, right? And
Yes,
switch two
switch
is not
one
filled.
is filled up, yes.
Two is not filled. Okay. First, which filled tend to be odd. Then
Uh-huh.
it will broke all the O's under it. That's
Yeah,
H.
we'll broadcast it, okay.
Switch one already has it on his ARB table.
Yeah,
So you just leave the orb. You don't need to go to switch two again.
okay.
You just
Yeah, it will
phone will
just
tell
send it.
you
Exactly.
not
Yeah. So that's the only time that it floods is only if it doesn't have it. So now H2 asking H7. You see that these people didn't even get the message because this guy, switch one, already know who H7 is. So it's not flooding anything, you just give answer. So that's that for uh that. And I don't know another question I could ask again. Um um yes, that's okay, that's just that. If you have understanding about this. And the other thing you need to be knowing is that if H2 is asking who is H10, when it gets to switch will secretly fill its ERP table with information of H2. So when information comes from H10, switch 1 will still fill information about 10. So when 2 is asking about 10, H switch 1 will register information about 2 and 10. When the message is coming from 2, it will register it. When there's a response, it registers that of 10. So that's the way it fills its ARP table. Then, uh-oh, what happened? Then let me get to the router.
I will be answer for another time.
Okay, fine. Okay. All right, no problem. So we've done hop and switch. So
Yes.
the next time is going to be router. All right, we'll call it.
When is the
Okay.
next class?
Okay, you can just let me know. You know that we are doing Wednesdays and Fridays. Other
Yes.
days, except in the night.
No, I think this night is I work. I understand. Night is
Sorry?
always little. uh, Night is a little bit less tense for me. You understand? But
Okay.
sometimes they have to all the things. But that night, it's always
Okay.
like now. If anyone that's coming this night, I wait till tomorrow.
Okay.
When you
Then we
can
can.
be me, I
o-
would have picked. I would have done it for the kitchen. Would have slept. So I can focus on this one.
Okay.
So I think that is a good one for me. And again, I don't know. I'm although I work as a travel agency manager,
Okay.
I do book. I want to do just I want to keep my career. I want to just
Sorry, I am struggling to hear you. It seems as if. Oh,
can you hear me now? Can you hear me?
yeah, yeah, yeah.
I said that um I am a travel agency manager. I do ticketing and reservation like for flight.
Okay.
Yeah. I want to go back. I want to go back to my IT world. I want to really go back. I want to be the career. That's why I'm taking class. So I'm a kind of person that when I do practicals, I learn more.
Yeah,
When I
it's
have my hand,
yeah.
when I do my hands on, I grab it fast. faster
Yeah.
than even with all these lessons too. I don't know. I was I was looking for it. I don't know how many months I can maybe after the training I can get a place to work. I don't mind even getting it with after my salary. I don't mind it. I just want to get the experience. That's all I'm not really after the money
Okay.
now. Any place I can work, I can have like an experience, hands on work my salary. I don't mind.
Okay.
Okay.
What we might need to do is you might still need to relate this to Mr. Hillary. Normally, sometimes
Okay.
people do come in to outsource uh, uh, people from us. So when they come like that, he'll just pick some one or two persons and assign to them.
Okay.
So just let him know so that in case when it comes up like that, he will have you in mind. If someone,
Okay.
maybe sometimes companies do come to outsource IT people like that. So if it's like that, he will just put you in the list. And again, we still, even if you sometimes you might have time, you can still come around our place and set up any kind of network. Although just with time when you must have advanced in this, you can just come around anytime, set up any kind of network, complex network, troubleshoot it, or just tell someone to disrupt it. You now check what went wrong and all of that, restore it
Okay.
back.
Okay. I think
So
that's a good one.
yeah,
That's a good one.
so you can set up any kind of complex network from our side. And
Okay.
maybe you can set it up. Someone can come and remove cable or do something wrong. You now troubleshoot it, know what is wrong and all of that. Though before then, you might still need to get some practical things done yet before you start
Okay.
setting up that. Although what we are doing so far now is just theory. You need to
Yes.
get some of
Yes.
those theory before we now enter the practicals.
Yes. Definitely. Are you going to be around tomorrow too?
Tomorrow is Thursday. No, I always Mondays, Tuesdays, and Thursdays. I don't always stay at home.
Okay.
That's what I was saying, except in the night. I will be free on
No, I mean
Wednesday, on
supposed to
Wednesdays
be
and
the
Fridays.
that you like by tomorrow.
Okay, fine. Tomorrow, I didn't even stop this recording. I've been talking about this, so
It's
I want to see if I can upload